Welcome to the industry talks of the second summit on gender equality in computing. We have 4 speakers for this session, but before we start, some practicalities. Your microphones will be muted for the duration of the talks, but you will have the opportunity to ask the questions at the end. So I would also like to encourage you to type your questions on slido.com, and the code is GEC 2020. You can use that for the entire session, and this will be available after our session. So I would like to welcome our first speaker, is Katerina Kalimeri, Cloud Security Lead at Oracle. Katerina Kalimeri has been active for more than 20 years in information technology and 15 years in the field of information security. Her know-how covers enterprise security architecture, identity and access management, data security, cloud security, fraud prevention, and advisory on various regulations. Katerina joined Oracle in 2007. In the past year, she has been working as cloud security lead under the auspices of Oracle Consulting Enterprise Security Competence Center, with operations in Eastern Europe, the Middle East, and Africa. As a member of EMEA Consulting Services portfolio leader, she's actively involved in designing Oracle services and more. During her career, Katerina has worked in various positions at Oracle, Adecom, and Ideal Group. She holds an MA from Leicester University and a Bachelor of Science from the American College of Greece, and she's a CISSP certified. Katerina will be talking about exploring the benefits of gender diversity in cybersecurity. Please, Ms. Kalimeri, please start your talk and slide sharing. Thank you.
Good morning. Thanks for the invitation to share my thoughts on this interesting topic. So allow me to share my screen. I hope my slide is visible. Angela, can we confirm?
Yes, it's perfect. Thank you.
Wonderful. So we all know that there is a significant activity which affects all of us regarding inclusion. And the message that I would like to share is that security, information security, cyber security is a tremendous opportunity to allow more and more women in position of active and senior roles because of certain reasons. First of all, I would like to thank you for the introduction that you had the chance to do to me and extensively to our team. And then, obviously, with that in mind, as you already covered, that we are operating a center of excellence with focus on enterprise security for an entire region which spans from Africa, Middle East, Gulf states, and Southeastern Europe, with a specific dedicated focus on cloud security, data security, identity management. And the most important thing is that we have already focus of inclusion with 40% of the people in the team being experts. And with that, I would like to kickstart my presentation by identifying a significant reason that security is at the cornerstone of IT as we speak. Starting from the fact that it is baked in every IT activity, in every project from the beginning. So a security project is not necessarily a project that has a single-minded focus. On the contrary, every IT activity is actually part of a security practice and a related stream. And this highlights that there are various people with roles and responsibilities that are actually actively involved in that, building products and processes, having the risk in mind, and ensuring that the life cycle of the deliverable and the project is aligned with best practices and ensuring that what we're going to kickstart and will result at the optimum behavior, both from the internal perspective and also from the external. And this is an exercise that encompasses all the stakeholders from day one. A second fact is that securities is also on the topic, on the focus of the board, of the management. So 44% of organizations, according to the latest research, multiple analysts are doing that. I just draw an example from IDG research, which identifies that the corporate boards actively participate in their security strategy. So there's a very focused and enriched career path ahead of us for multiple roles and purposes. And there is a constant communication between the management and stakeholders of security, with more than 50% of the boards actively briefed every quarter, at least quarterly, and more often. To couple this, there are information security management programs that are now addressing every aspect of activity from an IT perspective, and they're coupled with risk management. So all these are giving us are reinstating the fact that this is at the cornerstone of business. And last but not least, companies really are susceptible to issues related to security when it comes to their reputation. On top of the mandatory regulatory framework, which is spanning worldwide, both at the local, the regional, and the international level, which most of the times, especially for an organization that encompasses activities in multiple geographies, there is a cross-matrix obligation. On top of this, there is also the simple fact of identifying your reputation and damaging your reputation in case of a breach, in case of a significant security incident, especially given the fact that now the regulations are making mandatory to publicize certain events. For example, the most important one in Europe is GDPR, which has this type of mandate. And this is also at the highlight that the overall cybercrime cost is actually soaring. More than 600 billion is now the estimation, which is approximately 0.10% of the global gross domestic product is attributed to the risk and the cybercrime. That means that there's a whole field for professionals that they have to understand how IT processes and policies lead to vulnerabilities, to mitigate exposure to risk, which is high, and acknowledge the fact and mitigate the fact that it is only a matter of when, not if, a breach may occur. A final interesting fact comes from the fact that there is a significant gap as far as infosecurity skills are concerned. There is the latest update regarding this is that at least until 2022, 80 million cybersecurity jobs will remain unfulfilled and unfilled. Sorry. And that calls not only for recruitment from the outside, but also to a career and role re-engineering from the inside, which most probably IT professionals of all backgrounds will need to learn more and understand cybersecurity and obviously build relative skills. Going further down, I would like to highlight certain things regarding knowledge and skills and how this can be factored into the career path. Especially for women, there is a significant trend regarding the fact that the majority of organizations from every industry struggle to fill infosecurity roles. And those with security roles and skills indeed have actually a choice when they pick their positions. I can put my personal experience on this because I'm actually a product of this mindset. In Oracle, we are building, let's say, our own profile and further enhancing our career path in approximately 1 every 2 years on the basis of the demand and the way that the industry is getting further ahead and requesting certain types of specializations. And not only that, but there is a significant fact that only 2.5 qualified candidates exists for every security job. This is an interesting fact that comes from CyberSec, which is a dedicated engine for this type of endeavors, which means that investing in security training and education is actually aligning the job hunting odds in your favor. And as I said, you have an optimal opportunity to chart your own career course. So on top of hiring challenges, the organization are actually facing the challenge of turnover, which means that more or less managers are more often than willing to accommodate their security skill staff's request. So pretty much you can do a nice formulation of your own career development and build and charter your career for longer periods. This is a rare opportunity which is coming from the diversity and the challenging of the cybersecurity landscape. And of course, as I said, we have to reinvent ourselves very often, and new opportunities and new roles are coming across. I have specific examples to share. For example, the Data Protection Officer Office, which is something which started relatively late in 2018 for GDPR compliance. The Cyber Awareness Program Manager, and of course, cloud security and their architecture roles that are spanning towards the shift between the on-premise model to the cloud model, which is the dominant trade in IT. So, as women and as IT professionals, we have an opportunity to really make a difference and to ensure that our contribution, both at the professional, at the industry, and at the inclusion level, can be significant. On top of excellent education that we have, and in Greece, there are multiple academic institutions that are investing in this type of specialization, such as IT security, cybersecurity, risk management, and the like. I would also like to highlight that the industry certifications are very relevant because they are linked directly with specific trends and industry experience that we are called upon. And they're coming out both from the technology perspective, but also from the functional, the implementation, and the use case perspective. And on top of this, an investment in an industry certification shows the potential employer that you're further directing your career in specific specialized area and focused knowledge. And in that way, you can really shape further down your own profile. I have highlighted certain certifications that I find, and they are ranked first in 2020. These certifications are actually a reflection of the entire security continuum, because on the top, we have dedicated certifications that are addressed what we call information security management, with a highlight as the Certified Information System Security Professional, and the CISM from ISACA, IC² and ISACA. This is a holistic certification which is tackling the entirety of the security domains, of course, with an evolving dimension over time. So new topics are added. And of course, in order to retain your certification, you have to highlight and build the additional skills along the lines of the evolution of the standard. In the same logic, we have also the Certified Cloud Security Professional certification, which is a joint venture between IC² and Cloud Security Alliance. And this is at the heart of the cloud and the digital transformation, as we call it. In Oracle, we are building specific security practices that are focusing on those three certifications. And this is an excellent career path because you can go both from the technical role to more functional role and of course to more managerial role. In the middle, we have certifications that are more related with auditing, and they can address functions like IT audit, internal audit, of course, with always a holistic perspective. So the CISA certification is one of the most prevalent and highly ranked, together with CRISC, which is a certified in risk and information systems control, both from ISACA. And at the bottom, let's say, of the slide, but at the cornerstone of evaluation and significance is are more technical evaluations related with assessment, direct assessment, and the various practices in the IT systems and controls, such as the computer hacking forensic investigator, the certified ethical hacker, and of course the CompTIA security certified, and the Greek GRC certified essentials. So with all these certifications, there are distinct career paths that one can follow across the lines. Most of them are addressing mid-careers, which means individuals that have at least 3 to 5 years of experience. And this is an excellent investment also as part of your career path. I also want to address the dynamic element of mentorship, of aligning with thought leaders in the industry that can both guide you through their own personal story. How you can do that? You can follow them in LinkedIn, in their personal websites, highlighting them, addressing them in conferences. So the idea of alignment within a community is of significant importance. And with that, there are excellent initiatives that are addressing inclusion, initiatives that are focusing women in tech, women in cybersecurity. So we can even share further challenges when it comes to individualizing our career paths in alignment with our gender, with our culture, with our geography, and this type of things. So I would strongly advise that you also engage in this mentorship interactive mode with people that are inspiring to you. In summary, there is a significant opportunity for security. It's a strategic function which you can chart your career starting from the beginning up to the top, which you can be at the board, at the C-level position, at an individual contributor role, and these type of things. Armed with passion, drive, and flexibility, I really propose to evaluate security as a career path, since there are plentiful opportunities well into the future. Thank you very much. If questions, I assume this will be addressed at the end of the sessions.
We can address them now. If people have any questions, I think please raise your hands or use Slido. You can raise your hands here in the chat. Any questions? Well, thank you so much for this talk. It was really eye-opening, because I'm sure a lot of we have students here following, and it's very interesting that they find some career paths and see what choices they have. So any questions for Mrs. Kalimeri, please? It's a bit difficult to handle these tools, I guess, for people. Might feel a bit intimidated. But if there are no questions, I would like to ask, you talked about mentorship. And it's important that whoever is interested goes and tries to find people at conferences and different venues. Do you think we could have this as a part of the formal education setting, to bring people from the industry into the formal educational settings and see how we could have these mentorships in the academia?
Absolutely. Because that they give the grounds of having this as a constructive activity. But also, it's now with the internet and the digital, we have excellent opportunities to connect. I'm in LinkedIn. If you search my name in LinkedIn, it's as easy as that. The platforms are there. We have initiatives, meetups that are directly addressing IT, women in business. So there's a multitude of opportunities. I'm talking only for also not only within academia as a starting point, but also in terms of a continuous education, because they think that we all identify the need to evolve over time. So what I have to say is that the university can become really can build the groundwork and can shape this mentality that each student and graduate can further take it down the line in his own personal interactions in the industry. Things are becoming much more dynamic and much more interactive, and there's an excellent opportunity. And personally, I feel that everyone that has some sort of path in this field is willing to share. And this is a process that offers a lot of satisfaction both to the mentor and the mentee, because you always learn by engaging with people that are doing the things that you started, and you can share them back. So it's a very dynamic and interesting process.
So thank you so much. I'm sure this is something we could just discuss further at the end with all the organizers of this event, because it's a very interesting concept, the mentorship, and how we could explore it further. So thank you so much. Thank you. Now go to the second speaker. Is Sofia Tsekeridou, Senior Research and Innovation Manager at INTRASOFT International. Dr. Sofia Tsekeridou is currently a Senior Research and Innovation Manager at the Research and Innovation Development Department of INTRASOFT International, heading the Security and Safety Lab. She previously had held a position of Associate Professor at Athens Information Technology, heading the Multimedia, Knowledge and Web Technologies Research Group. She has acquired an Electrical and Computer Engineering diploma and a PhD in Computer Science, both from Aristotelis University of Thessaloniki. Dr. Tsekeridou has more than 20 years experience in research, development and innovation activities, having contributed as senior researcher, senior project and technical coordinator, as well as senior technical architect and leader of software development teams and software integration and testing activities in more than 40 national, industrial and EU-funded research and development projects in the areas of multimedia processing, e-learning, data analytics, information security, cybersecurity, search engines, recommender systems, and knowledge engineering in diverse application domains. She has published many papers at international scientific journals and conferences, and has contributed to the TV Anytime and W3C standardization bodies. She has served as a reviewer to many international scientific conferences and journals, and as an evaluator for project proposals, as an organizing chair, tutorial speaker, and program committee member in many conferences. Dr. Tsekeridou is a senior member of IEEE and a member of the Technical Chamber of Greece. She's an active validated member of Europol's Data Protection Experts Network and has received personnel security clearance in 2019 from the National Ministry of Defense at EU secret and NATO secret level. She will talk to us about technological trends and innovations in digital security and public safety information technology solutions. So please, Dr. Tsekeridou, you can start your talk and slide sharing.
Thank you very much for the introduction as well. Let me share my screen. Seems I have a problem sharing.
You should be able to now. Can you try again?
Yes, now I can. Can you see my?
Yes, you may want to also make your slides into presenter mode. Great, fantastic.
Great, thank you very much for the invitation to actually give an interesting talk to the Gender Equality in Computing Conference this year. It is an honor. I will be a little bit more technical. Hope it will be easily digested from the participants. As I'm a member of the Research Innovation Development Department of INTRASOFT International, I will try to give an indication of the current research activities and innovation areas in digital security and public safety information technology solutions. First, let me briefly summarize what we do in our Research Innovation Development Department. Of course, we are involved in a number of EU-funded research projects from long time ago, starting from FP5 framework. And we undertake both project coordination as well as technical coordination, system integration, architecting systems, and contributing to core technical competencies in these projects. but we also focus on innovation in order to lead the results of these projects into the market, if possible, cooperating with our commercial departments within the company, or as well as with external collaborators when an opportunity is seen and the strategic goal of the company is defined to be met. So starting first with the area, or the quite wide area of digital security, privacy and trust. I'm sure you have heard actually quite many times these terms. They are quite trendy these last years, especially, for example, trust and privacy enhancing technologies. These are quite in the focus for research and innovation, especially, as also the previous speaker mentioned, with the advent of relevant regulations like GDPR and the need for sensitive data protection as well as personal data protection. So these technologies have emerged because of this need, but also to increase the protection from cyber attacks, so that data is not shared or circulated that may be sensitive, or people may use to impersonate other people. Cyber attackers may be used to impersonate people. And of course, once someone invests in such types of technologies, then his or her solutions, especially IT solutions, would have wider market penetration, because they would enable, of course, what is required, the user in control of his or her own data, and increase of the user trust in the systems. Such technologies range, of course, from user consent management systems and GDPR compliance assessment tools to techniques like data minimization and pseudo-anonymization, as well as zero trust technologies, and the definition of data governance models and policies and ways to enforce them. Then another area that quite significant research is done is to define distributed models and tools for securely sharing such sensitive information across trusted partners, and data integrity techniques. So the trends there with respect to technology are the quite widely heard blockchain and distributed ledger technology, and use of smart contracts for the enforcement of data access policies, for example. And quite a new area of research currently are interledger transactions, how different ledger technologies actually would interoperate among each other, as well as, of course, working more on advanced methods of encryption and obfuscation information security. Another area of research is federated threat intelligence and machine learning, of course, for this purpose. And this starts from defining relevant taxonomies. There is, of course, ongoing work on the definition of the STIX 2.0 taxonomy, and there are a number of ongoing work from Europol and ENISA on defining the different threat landscape in the diverse, of course, domains of digital service operation. And in this area also to define distributed models training, as we call it, federated learning paradigms, and retraining so that trained models are much more accurate and reliable, but also we face in this way the problem of having access to data that providers may not be providing in a centralized manner. Continuing, there are trends actually on developing a secure software, starting from the design phase, of course, until the release of the software, following security and privacy by design and by default methods, and DevSecOps approaches in which security is introduced in all software development lifecycles, starting from design until the deployment and the infrastructure where the software will reside. And a number of tools and methods are used at various phases to assess vulnerabilities to the software or the hosting infrastructure per se, and resolve them. And finally, there is a new trend for cyber risk assessment and recommendations for optimal protection, especially, as the previous speaker also mentioned, of the quite significant impact on companies offering digital services when, for example, attackers manage to penetrate the data centers or steal information and make their services non-reachable, etc. So this creates economic as well as reputation impact, which is quite costly for an organization, especially small and medium enterprises, which actually may not be able to manage the situation and fail. So now, having discussed a little bit of what are the research areas and innovations in digital security, trust, and privacy, kindly allow me to present some of our ongoing work in indicative projects we participate of have coordinated. For example, one such project is the Phoenix project. It's about securing electrical power and energy systems against extensive cyber and privacy attacks. In this project, we lead actually the research and the development on the incidents secure information sharing among search and research and energy critical infrastructure operators, capitalizing on distributed ledger technologies, using smart contracts, and researching on inter-ledger transactions, of course, in collaboration with other partners of the consortium, and also on federated machine learning approaches against zero risk. So you see here quite a high-level architecture of this project. Since energy critical infrastructures are distributed throughout Europe, and when an incident happens in one, may have cascading effects on others, or the information may need to be shared with others and with the right authorities, so that others are also prepared to manage a similar case of attack. The project actually envisions providing such type of sharing platform, but in a secure, trusted, and privacy-aware manner. We also participate in a working group of IEEE on defining a blockchain governance standard, and specifically in the interoperability subgroup, because when different ledger technologies are used by different critical infrastructure operators, this is quite an imminent research topic that requires immediate solutions. Of course, this is ongoing research, so no final results yet to present. Here, I also have a slide to describe a little bit how the federated machine learning approaches against zero-day risks is tackled at a high level, because going into details will be quite difficult to digest. So the idea, as I mentioned earlier, is to train the different models at the local sites, the local individual critical infrastructure operators, and then these models are again retrained at a centralized federated server. And of course, decisions can be made about incidents and information sharing at the incident information sharing platform. Now, another project in which we developed a toolbox for cyber risk analysis, assessment, and cyber insurance and security measures recommendation is the Cybeco project that has ended last summer, in which, of course, collaboration with many external parties, especially SMEs, has been done to assess the risks, as well as an extensive study with respect to that, according to what assets they have in and what security measures already. And in this way, for example, recommend, you see here the different threats and the organization, what systems, actions, and what impacts were more important for them were assessed. And here the modeling by gathering all this information from the interested entity of the risk cases was taking place. Of course, part of the information is what impacts for the specific organization would be more vital to address in order to make the automated recommendations. And part of the entire toolbox was also to provide recommendations about cyber insurance packages as a new area that also insurance companies are looking into. Some more advanced, especially in the Central and North Europe, some less advanced in South Europe. And then after gathering all the information and modeling using R, we were able to recommend different packages according, of course, to elements like cost, like level of security, etc., and what is already in place, etc. Now, with respect, going now to the area of digital safety and protection, because yes, digital security and cybersecurity is quite vital, but also we have to look into the public safety and the citizens' protection, which is also quite a hot topic nowadays, especially due to terrorist attacks, for example. What are the trends with respect to research and innovation are to come up with actually quite effective and timely tools for real-time situational awareness, coordination of many different response teams, and relevant decision makers, relevant authorities for decision support. So quite challenging still is how do we aggregate the necessary data in real time, harmonize, analyze, and get insights of what is actually happening in almost near real time, of course, capitalizing on a number of different sensors within a smart city context, for example, or even open data sources. Then to come up with the standards for the modeling of the respective data and their governance, because this is very vital to have different tools interoperate together. Work on advanced visualization methods, even including 3D and VR, and visual analytics, so that information from the data processing tasks can be presented in the way that people will really understand what is happening and will facilitate even better decision support. And of course, provide automated, as much as possible, recommendations of standardized response actions. So again, standards come into play, and a definition of standard operating procedures. Then another area of research is involving citizens in the safety of themselves as well as of the spaces they live in. And a number of tools and research has been done on how citizens are engaged, what methods and tools they are used for active participation, how the authorities communicate with citizens. And we've seen that nowadays with COVID-19 and registering in Viber and get messages, which is the simplest form. But what is quite important when a citizen is active in participating in the safety of his or her own city, for example, is how do I validate and have a citizen being as a trusted member to provide such information to law enforcement agencies, and how this information is indeed valid. Okay, so some results of indicative projects that we have participated in this area of public safety and protection is, for example, ITRAC, which is about the protection of humanitarian missions in regions of conflict. An open source, actually, software project has been the outcome of this project. Indeed, in that case, humanitarian workers going to a humanitarian mission are in real danger. Many have lost their lives. So this indeed a system aimed at monitoring their routes and themselves, and providing tools for them, reporting any incident that may be peculiar or strange, or even using sensors as well and open data sources like live UniMap get information about ongoing incidents and threats near the area where the mission takes place, so that the system warns them early enough to take protection. Here is some, okay, I forgot this. Here's some screenshots of the system that has been developed, tracking people as well as vehicles, not only people, but also getting, this is the command control, getting information about incidents being reported, or information about potential incidents where you see the question mark, that are gathered from open data sources. Another project has been one that we have participated, which developed community policing tools. In this one, we developed technologies on how to have citizens being active actually and validated, of course, in community policing actions. For example, neighborhood watch people. This is a screenshot of the portal that has been developed, and of course its citizen was able to see what incidents he or she reported and communicate with the law enforcement agency, be able to validate himself or herself, and get more information and warnings from law enforcement agencies about an incident like a theft in his or her neighborhood. Of course, these involve not crimes that were quite serious, like murder, but actually the type of petty crimes, okay, so that citizens are not endangered by reporting something quite serious. And finally, I hope I have not tired and not gotten more of my time now. A project that we have been involved as well has dealt with health emergency management, like what we are addressing actually now with COVID-19. And there, of course, the entire consortium has developed a system for multi-agency coordination, situation awareness, and decision support for effective response, both for natural disasters, terrorist attacks, and pandemics. In that project, we developed, as I said, SmartLink health reference model based on existing standards and a real-time data aggregation harmonization component, which was necessary in order to harmonize all the incoming data coming from first responders, from volunteers on the field, as well as from open data sources. So you see here how many people, agencies, first responders, so the decision maker, the actual agencies, the first responders, police, ambulance, fire brigade, coast guards, etc. Then tools for citizens as well as first responders, and open sources that fed into the system in order to be able in real time to assess the situation and provide effective coordination. I hope I have not tired you. This summarizes actually our experience with respect to current innovation and research fields, and especially in the digital safety and security area. And in which, of course, a balanced set of male and female engineers and researchers has been involved. I'm happy to receive your questions, if any.
Thank you so much for this, the fascinating works you showed us. Questions, please. Any questions? Any questions for Dr. Tsekeridou? Till they think of a question, because I know people feel a bit intimidated after all this excellent work you do. You talk about, it was a question, that it's a question I will ask afterwards to Mrs. Kalimeri as well, because there's one in Slido, but it's on the similar line. You talked about this IMPRESS project and the COVID situation and the new challenges. And I think COVID is a part of how it has affected everything in our lives. So how much of that have you foreseen, the actual, Because when you wrote the proposal was a few months back before the actual COVID situation. So did the COVID situation increase your workload, or it changed it qualitatively? Were there challenges that you hadn't foreseen, things that changed qualitatively the work you do on cybersecurity?
Actually, the COVID situation changed a lot in both our work and personal lives, but it made us also realize how resourceful actually we can be in order to find solutions to resolve issues. For example, it changed the way we collaborated. Okay, too many online discussions, however, took place in order to address that. Many people were afraid of how to handle or what to do. Even especially in the way we work with projects and pilots, some pilots ended up moving later than earlier because they were not. It was not possible to be conducted physically. Such that the pilots require that. A number of other organizations in Europe closed, and so people were not responsive, and we needed to make up ways of how to proceed with the work and not introduce significant delays. But I think it was managed quite well in most of the situations. And talking again about our line of work, the European Commission has been actually quite caring and helping in situations where indeed something could not be prevented, and inevitably some small delay would happen. Mm-hmm. So yes, we always, especially in research innovation, we always face challenges. And we always try to find solutions. So this is what we know how to do it. And I think we can manage in every situation.
And thank you. And here's one more question. And I think it's for both of you, it's for you and for Mrs. Kalimeri. How secure do you think the new apps for monitoring social contacts with regards to COVID-19 are? So it's a very, very interesting question.
Yeah. Sometimes there is a lot of trade-off, especially if it concerns the safety of people. Even GDPR provisions that the special situations and circumstances like safety. Some rules about personal data may be raised. I mean, it's not possible to do your work correctly if you're always required, if you're always required to respect the privacy and data, etc. I understand this may sound a little bit strange for people, but what would you put first? Your own safety or the protection of your person? It's always a trade-off. It doesn't mean that the data will not be protected. Simply, we need to see whether we can, in some cases, lower the protection levels versus the benefits we get from providing services for better safety.
And Ms. Kalimeri?
I would like to emphasize that this is why the cybersecurity risk approach is getting, let's say, formalized, because every situation has its own peculiarity. Of course, when it comes to protecting specific citizen rights, like GDPR, this is the discretion and the way that consent is being managed. So from the system perspectives, the systems should be able to manage consent end to end. In that way, we give the subject of the data a say and a direct action on every systems of record. So this is the obligation from an infrastructure perspective. We should be able to accommodate to this requirement in every project. This gives the security a cornerstone in all flavors of IT, which is a big difference from what was happening in the past, which was more like a voluntary, let's say, intention on the owner of the infrastructure. Another thing that I would like to highlight in that is what we call a shared responsibility model, especially when it comes to joint management processes that are encompassing multitude of infrastructures. Like, for example, with the cloud, we have, of course, the owner of the data and the processor of the data. So all these processes and the risk that comes at each data lifecycle is also part of the equation and the analysis that we do, the assessment of the risk. So the answer is that for every part of the data lifecycle, there should be the evaluation stage, the option to implement control, and the option to engage the stakeholder, be the subject of the data, the processor, or the owner of the data. That's, I think.
Thank you. I see we have questions here, but I think we should move on and discuss this further at the end. Thank you, Ilianna, for your question. We might have time to address it at the end. Otherwise, we will take this asynchronously. And this is why we have Slido, so please do use it. It's very important to have all your questions there. Now, our third speaker, Ilianna Kollia. She's a senior data scientist and cognitive computing expert at IBM. Ilianna Kollia is a senior data science cognitive computing expert at the IBM Global Business Services Department in Athens since 2014. She holds a PhD in the area of artificial intelligence and machine learning from the National Technical University of Athens in collaboration with the University of Ulm in Germany. She obtained a Master of Science degree from the University of Oxford in 2010 in the area of artificial intelligence, and an MBA from the National Technical University and the University of Piraeus in 2016 in the area of techno-economic systems. She has participated as a research associate in several research and development projects at the National Technical University of Athens, at the Institute of Communication and Computer Systems, and at the University of Ulm. She has accomplished a large number of IBM projects in various domains, including healthcare, banking, telecommunications, energy, and transportation, and has been awarded the IBM Asset at global level. Today, she will talk to us about how artificial intelligence can transform the way we live. So please, Dr. Kollia, start your talk and slide sharing. Thank you. Dr. Kollia. Do we have a technical problem? If you could, you can unmute your microphone, yeah?
Okay, thank you. Thank you for the introduction. One moment to share my screen. So you see my screen now?
Yes, it's perfect. Thank you.
Okay. So in this talk, I will speak about the new era of artificial intelligence and cognitive systems. So there are three distinct eras around the years which have appeared. So in the beginning, there was the tabulating systems era, in which the tabulating machine was invented, and that was around 1890s to 1940s. Then we moved on to the programmable systems era. In this era, computers did massive math calculations very quickly, and they could reply to if-then-else scenario. But the problem was that the user had to interact with the machine in the machine's own language. And now we are in the artificial intelligence cognitive systems era. In this era, machines are trying to interact naturally with humans, so they can understand human language, they can respond to humans, and they can also learn from their environment. And the goal is to reach a point at which we simulate exactly how the human mind and the human processes work. So there are three capabilities that differentiate AI cognitive system from the traditional programmable systems, and that is understanding, because cognitive systems are able to understand human speech and interact with users. They are able to reason, so they have knowledge, and using reasoning, they can draw interesting conclusions and inferences from this knowledge. So they can form hypotheses, and they can use their knowledge to either prove or disprove this hypothesis, just like humans do. And a very important capability of a cognitive system is their ability to learn. So with every interaction they have with their users, every new piece of information, they use this in order to learn and expand their knowledge. So with time, they get better and better in order to be able to interact naturally with humans. So AI, you can see AI has 3 layers. So in the one layer, there's the learning layer, in which techniques like machine learning are used. So machine learning, you all have probably heard of deep learning, that is currently a hot topic in the research community. Then we have the layer of perception, which is more about this interaction of the machine with humans. And we have the layer of understanding, in which knowledge representation and reasoning techniques are used in order to draw interesting inferences from the knowledge that the machine has, the intelligence system. So now moving on to business, artificial intelligence is driving digital transformation in the business world. According to data economy, AI will help power the next phase of decision-making processes. The Gartner press release has made an interesting article which says that in 2021, AI will generate around 3 million in business value and recover around 6 billion hours of worker productivity. So you understand these are very big numbers. And also it is stated there that AI will create more jobs than it eliminates, which is interesting also. Many businesses have already, and companies have already started using AI techniques. So using AI, companies are able to unlock the value that is hidden within their data in new ways. So they are able to predict the future outcomes. They are able to optimize people in the sense that they can leave people do higher order jobs. They can automate decision and processing by finding out hidden insight within the data. And they can create new business models that are transparent and trustworthy, which are 2 important properties that need AI models to have. And it's interesting that 72% of the companies that have already used AI techniques say that they have increased their revenue. Now, some statistics from the R&D community, according to the AIindex.org since 1990, there are 9 times more papers in AI. There are also, since 1996, 3.5 times more large AI conferences, 14 times more AI startups since 2000, and 4.5 more jobs since 2013. So you understand that there's a significant progress in AI field within the last couple of years. In the diagram here, you can also see the classification error over the ImageNet dataset during the year. So ImageNet, if you don't know, is a standard dataset that is used for understanding the accuracy of machine learning models. So it contains around 14 million images split within 1,000 categories. So you see that this error is continually rising from lowering from 2011 to 2016 that the figure shows. And it's interesting that if you see after 2014, the machines have outperformed the human. Here you can see the error that the machines make is lower than the one that humans make, which is interesting. Also in the slide on the right hand side, you can see the number of AI papers from 2010 to 2019 that were about AI. So you see, particularly from machine learning, which is a part of AI. Here, okay, they have put it differently, but machine learning is part of AI. It's the yellow line. You see it's increasing in significant rates during the years. Here I have put a slide about women in AI research, which is interesting because they're not such high, the rates of women. So this slide shows the percentage of papers with at least one female author. And the yellow line is about this percentage in non-AI related fields. The black line shows this percentage in AI related fields. You see that the numbers are quite small, less than 40%. In Greece, which you can see somewhere towards the lower of this figure, you see it's less than 20%, the percentage of the female authors in AI papers, which is low. This needs to be increased. So let us now have a look over the developments of IBM within this new AI and cognitive era. So you probably have heard of Watson. That was a tool developed by IBM that won 2 great players in the Jeopardy challenge. So Jeopardy was a game where a presenter asked questions and the 3 players, including Watson, answered. So, and Watson won this game. That was actually the second great challenge that IBM took. The first one had to do with Deep Blue. That was a tool developed by IBM, an intelligent tool, won a very good player in chess. And there is another challenge which is currently active that started in 2012. And last year, there was online a debate with a very good debater. So this is IBM Project Debater, in which is a system that is able to debate with humans. So that is important because it can help humans build persuasive arguments, so in order to take more informed decisions. So that was a presentation where IBM Project Debater debated a very good debater. And it's interesting if you want to know, if you want to see. Yeah, now there are some available AI services in IBM Cloud which one can use in order to build their own applications, and that's easy. So, for example, there is Watson Assistant service. This service can be used in order to build chatbots, so natural language interfaces. There is also, for example, a natural language classifier, which classifies pieces of sentences and paragraphs in specific concepts or entities. There's machine learning service, where one can create and train and deploy machine learning models. There's also speech-to-text or text-to-speech services, where one can convert between speech and text formats. Or tone analyzer, for example, this can be used in order to analyze the tone of a document, so to say whether the person who wrote it expresses happiness, expresses interest, or what kind of emotion this conveys. There is also visual recognition, for example, so you can recognize objects and events within images. So there are several services. You can have a look. They are available in the IBM Cloud, which one can use, integrate into their application to easily add some AI techniques in this. Okay, so here I have put a deep neural network, that's a convolutional neural network, which shows that you can give as input a picture, an image of something, and as an output, it can give you the concept or what appears in this image, the objects in this image. And it can do this through several layers of neurons. So some layer may identify the edges in the image, some other may identify features, some other combination of features. So that's why we use this deep neural network today, because they have good accuracy. But the problem with this deep neural network is that the explainability. So it's not easy for someone to explain why the neural network did make this choice. So identified cat, for example, in this picture. And that's an issue, and that's important, particularly in applications like healthcare, where, for example, if a system says for a patient, if a system that has patient data and says that the patient should follow some treatment or something, the patient needs to know how the system drew this conclusion. or also in the banking domain. This is important because if a bank rejects a customer for taking a loan, for example, the customer needs to know why he or she was rejected, and so that he or she needs to know what she can do in order to not be rejected the next time, for example. So explainability is a current research topic in AI, and it is very important. For this reason, IBM has developed an open source tool that's AI explainability toolkit that's developed by IBM Research, which provides several algorithms which can help explain the outcome of machine learning models. So everyone can use this. This is open and it's interesting to have a look. Another interesting development that's related to the current situation of COVID-19 is a development made for novel drug discovery. So we have developed some IBM, some AI generative models that could handle 3 COVID-19 targets. And so this has resulted in around 3,000 novel molecules, which were found by the AI algorithms. And these molecules were given to pharmacies or to doctors so that they are able to see whether these molecules are a suitable drug for tackling the COVID-19 disease. So that's also an interesting in this year's development. Now, moving on to Greece, there are several interesting developments in this field. For example, Watson for Oncology, that was a development we have made in GEA Hospital, where we have provided a tool that's able to diagnose and to suggest some treatment for cancer patients. So the tool gets as input information about the patients and the results of their exams and every information that the doctors may have for the patient. And the system is able to suggest a treatment plan. So it's doing this by ingesting every online and also proprietary journals or articles that are available. And it manages to suggest possible treatment plans for the patient. And also the exact doses that one should take and everything. And also the important thing here is that it also gives the evidence for that. So it can help the doctor to see where exactly the result was based. So the doctor can see the exact article on the exact piece of work that suggests that this treatment is suitable for the specific patient, which is important because this increases what we discussed before, the trustworthiness and the transparency of the models that generate the outcomes. And that was good because there were some doctors which found in this way work and articles that it was not possible to find without this tool, since there are a huge number of articles there in the web, which is difficult for a human to search them all. Another interesting development was the Watson Assistant for Citizens, which we did, that was a chatbot, which we did during these COVID-19 days. And that was developed for the Ministry of Digital Governance. And it contained the user, the citizen, could ask in free text, in a natural language, questions about, for example, private or public services. So their working hours or some other details about, for example, reference hospitals. So the citizens could easily find details by asking questions in their own language using this chatbot. Another interesting work is a big data processing system and the chatbot that was developed for an airline company. In this project, there was data were aggregated from several sources that were available. So data were aggregated from customer databases, from databases regarding flights, from databases containing some analytic information, and these were aggregated in one area that what we call data lake, and this data were able to be processed using machine learning techniques, and interesting insights could be extracted from this data. And apart from this, a chatbot was created that where the user could ask a prototype, that was a prototype chatbot, which could answer frequently asked questions regarding, for example, milestone bonus or baggages. And the user could also ask specific questions, so questions about flights, the details of flights, about the status of flight, or about the schedule of flights. So these were some developments I would like to share with you. These are not exhaustive. There are many more projects and that are currently running or have already been completing in the AI area. But I think they can give you some understanding of how IBM is working in this area. So that was all. Thank you for your interest. Do you have any questions?
Thank you so much, Dr. Kollia. It was fascinating for me. At least it speaks to my heart because I'm a psychologist. So I see the other end of the spectrum there. So I really like this talk. We do have a question, and is here. What is in your opinion on the debate about gender of chatbots, since most chatbots or AI technologies have female persona?
Yes, it's true. Usually chatbots use a female persona, but okay, this maybe states as bias, but in fact there are tools that could handle bias, and IBM has one such tool, which not only okay as far as this is concerned, but also for processing, for data analysis, and for the use of machine learning models. There are tools that are able to identify if there is some bias during the training of the model, so as to avoid such bias. But yes, it usually holds that female personas are used for chatbots. Yes.
And we also have another comment here that is not bias, it's just beauty. So yeah, but just to take this opportunity to tell you that at 3 o'clock we have the special panel about artificial intelligence and if it is gendered. So I will encourage you to participate. If anyone of the participants would like to participate, that would be very interesting. When we could take these gender issues on the artificial intelligence, because it is very, very hot topic, it seems, and everybody's interested. So thank you so much for this, and the enlightening slide about showing the Greek reality with artificial intelligence. And this is also something we should discuss further when we finish everything later on today with the organizers of the summit. We could discuss further, because indeed it seems like we need to work on that area. So thank you very much. So for our fourth speaker, Nika, Machine Learning Product Manager at Google. She's based in San Francisco, and this is why we can't have her live today with us. She's on a different time zone, and that's why we have a video. But Nika works for Google as a speech AI product manager. holds a PhD in computer science and epidemiology from Imperial College London, and is also a part-time teaching fellow at Harvard Business School's analytics program, when she runs a forum series on product management. has delivered 3 TEDx talks and has received international recognition, including the Woman of the Year 2018 award by Every Woman, as well as a Women in Science and Engineering Influence Award in 2015 for empowering the women in technology community in various ways. is also actively involved in the startup scene, as she serves as an advisor for 2 startups in the edtech space and as a mentor to early stage startups. So we can play the video, and for this particular one, please use Slido, because then she can also see your questions and will be able to answer them afterwards. So thank you very much.
Hello, everyone, and welcome to my talk on the second summit of gender equality. My name is Nika, and I am a machine learning product manager at Google. Today, I will talk to you about how AI can actually transform home automation. My goal is to inspire you to think outside of the box and explore with me how computer science can change the world's daily lives. First of all, a couple of things about me. I have a PhD in computer science. I focused on social phenomena and epidemiology, which is quite timely with what's going on in the world. I did data science at Facebook back in 2013 and then joined Google full-time doing machine learning product management in 2014. I worked in London and then got relocated to California, so this is where I am at the moment. So for decades, people have been dreaming about the future. In 1948, it was a comic. It was called The Real Fact, and they actually nailed it in predicting the future. It mentioned live satellites and feeds and notification systems, even online schools. In 1962, The Jetsons, it was a TV show that I loved. It started appearing on people's TVs. The Family of the Future, where they had home computers, the internet, microwaves, and they even have cell phones. In 1977, as you know, we saw the appearance of AI assistant droids, C-3PO, R2-D2, characters that we love. So this is when we first started seeing the power of AI through the eyes of droids, programmed for etiquette and protocol. In 1985, we saw Back to the Future, where we first discovered wearable tech. And then in 1985, we experienced this new world, and it was completely science fiction. So Marty McFly was wearing these glasses. We would never think that it would actually be happening in this world. But then you see in Snapchat released these glasses that had cameras here. So what we were seeing in the TV actually became a reality just a few decades later. In 2002, Minority Report, Tom Cruise was using a gesture-based interface. And then you can see it's now a reality with Leap. You can actually control drones. You can move your hands around like this. In 2017, there was Blade Runner, where he is having a romantic relationship with an AI assistant. Or in 2013, Her. Again, the actor has an AI assistant that's helping him throughout his life with his daily tasks. Which is exactly the reality now, right? So you have Siri, you have Google Home, the assistant is with us at all times and they can help us. They send us notifications, you can ask for the weather, you can ask for more complicated questions. So what we were seeing in the TV is now actually the reality. But what is it that made us dream of all these things? Why were all these movies and shows were being created for AI and in the first place? Well, it's the machine intelligence that actually lies in them that made these dreams amazing. And this is why I'm in this field, because it's such a fascinating field. So Google's mission is to organize the world's information and make it universally accessible and useful. First of all, I'm sure you all have heard from AI, machine learning, and deep learning. I just want to quickly explain the differences. So AI is the biggest kind of bucket in there. AI means that the program can sense, reason, act, and adapt. Machine learning falls within AI. So in machine learning, algorithms whose performance improves as they're exposed to more data over time. And deep learning is a smaller backend within machine learning within AI. It's a subset, and in which multi-layered neural networks learn from big amounts of data. So one important technology we use is neural networks. I am sure a lot of you have experience on this, or there must be more presentation on this. And there are many kinds of technologies we use for machine intelligence, but the most important one is neural networks. So this is a mathematical model. It takes some input through a series of processing steps, and it essentially provides some output. Let me give you an example. So given a data set that comes in that has photos of dogs or cats or like a car and things like that, once they go through a neural network model, the output will be a label which will categorize these photos into this label. So the model will be able to predict with some good probability whether the photo is that of a cat or a dog or a car on an apple or a flower. Here is an example where you can use, it's a more simple example where you provide a cat or a dog. In order to train the model, you need to provide data that have a label. So you provide the cat and then you tell the system, this is what a cat looks like, or this is what a dog looks like. And once you have enough data to train the model, the output is going to be as close as possible to the reality. So the network is composed of layers of artificial neurons, and we adjust the weights using an algorithm called backpropagation. The input is raw pixels. So what you see on the left over there, what the model takes in is just the raw pixels. And the output is the probability of whether the input is a cat or a dog with some score. So the output can be, hey, by 78%, I think this is actually a cat or a dog. And there are power functions that neural networks can actually learn. It doesn't just work for photos, right? So using an image as an input and an item that's in it as an output, yeah, you can also provide other inputs. So you can use neural networks to see images, to hear a sound, to translate between languages. Here's an example. So this is the technology that actually powers Google Photos. If you haven't tried this, you can go to Google Photos and type in a search to say, okay, give me all photos of dogs or water or a sunset. And you'll be able to pull up just the photos from that specific category. So Google, there is a rapid acceleration use of deep learning, and it's actually used across products like Android, apps, maps, Gmail, photos, speed, search. What I've been focusing on for 7 years is speech, and I will talk to you a bit more about it. So there is actually a lot of data in the world, right? So Wikipedia has 23 billion words and 40 billion textual lines in Street View. We didn't realize how valuable the pictures were originally, and later we revisited and extracted all this additional value. And you know, this can produce incredible products. So as you can see, Street View, if you haven't tried it, you should. You go on Google Maps, you hit on an icon, and you're able to actually navigate and drive through your most popular streets. And through these photos, we can see where the traffic light is, where the traffic signs are, business names, and you can do, there's so much potential for getting the data, putting it into a machine learning model, and improving people's lives. I had a video that wasn't able to play. So let me just talk to you about an example where the machine learning looks at the image here. It's an exit sign, as you can see. And once you put the app over it, it knows where the text is, and it translates the text into the language that you speak. And this is an incredible feature of Google Translate, because no matter where you are in the world, you will be able to understand, you will be able to use this app on menu items and be able to know what you're ordering, right? So this is very, very important. Smart Reply in the inbox by Gmail. I don't know if you ever had a chance to try this, but on emails, the model will predict what you should reply. And as you see at the bottom, you can pre-fill some of this text. So in this example, it says, I'm working on them. And this saves so much time of typing and retyping the exact same thing. This is a great application that I was using a lot, and it's just life-changing. So you may have also seen we open sourced our own machine learning platform, TensorFlow, and we're continuing to develop it and add new features and to make the platform faster and easier to use, as well as make it more powerful. It's important for us that the field advances faster too, to accelerate great technologies and opportunities for people all over the world. So look it up if you haven't. So machine learning is already making a huge difference out there, and there are so many opportunities. And there are many Google products that I will talk to you about a bit later for home automation, but there are beyond core products like applications on health or robotics or smart platforms, we can accelerate progress worldwide with machine intelligence. So let's focus a bit more on what I've been working on, which is the smart home. The Google Assistant, I don't know if you've ever tried it. Wherever you are, it comes with you. And it was a great idea to say, okay, it's been all over when I'm outside at the home or home and having the phone with me, but why don't we embed the Google Assistant on a home device? And if you find new ways to interact with technology on this device, this is how home automation can be truly fascinating. And back to the initial slides, it can actually have a science fiction application, if you will. So there are new ways of interacting with technology, and this is what I've been working on. So people don't just input text queries anymore. They actually say a lot of their question. And what I do is I try to understand what people are saying from all over the world with any accent. And we are trying to be able to answer them. So here's a model of a speech recognizer. It uses machine learning to take the raw sound, as I showed you before, in the same way as I would input cats and dogs. So it takes the raw sound in it, and it goes through a speech recognizer, a machine translator, and then a speech synthesizer. And it can actually understand what you want to say, and it can answer back to you in a matter of seconds, just by going through this model. So if you take the speech technology and the assistant and you put it in on the device, like you can see there, you can do so many things. You can set a timer. You can say, for example, hey, how much time is left for my pizza timer? Or you can access your calendar. You can play music. You can say, okay, play this song in my TV. So it's this world where there's this interconnectivity of devices, and the goal is to make our lives better. You can also change the temperature. If you say, hey Google, make it cooler, this is going to speak to your Nest device, and Nest is actually going to be changing the temperature. You can change the light colors. If you buy Philips hues, and you can say, I'd like my living room to turn blue or red or something like this. You can make phone calls as well. Okay, Google, call mom. Sure, I'm calling mom. And if they have a device with a screen, you'll be able to see each other with a screen. You can also purchase groceries. For example, hey Google, order some paper towels. You can watch shows. So you can say, okay, Google, watch Stranger Things from Netflix on my living room display. So there is this interconnectivity of entities. For example, Stranger Things is a show, and then Netflix is a provider, and then living room display is a device. So the assistant can actually put these complicated sentences together and make your life better by giving you what you need just by you using your voice. You can play music, as I mentioned, and these are the screen devices. So there are devices with screens, and you can talk. You can have video calls with your family. You can see important information about your daily commute. You can see the weather, notifications. This is just the future. So with all the above, technology is all caught up with sci-fi, like I said in the beginning. And sharing of data between connected devices happens seamlessly. It happens constantly. And we live, honestly, in an amazing era where we're experiencing only the beginning of machine intelligence. And I'm just looking forward to seeing what's next. How much better can our lives get in the future? For example, can we just have a smart fridge that knows when to order new milk? Can we control our home remotely when we're not there? Which we already can. Can we have holograms? There's just so many applications, and I'm just excited to see what's going to be next. With that, I'd like to close with something we worked a few months ago. So this is the remake of one of my favorite movies, Home Alone. And this is what the main character, Kevin, would be like now if he had these devices at his home.
What's on my calendar today?
You have one event called House to Yourself.
Oh, yeah. You Google, add aftershave to my shopping list. Hey, Google, remind me to clean these sheets later.
Okay, I'll remind you.
Too bad ACM.
Someone's at the front door.
What do I owe you?
Looks like you paid online.
Keep the change, you filthy animal.
Okay, cool.
Hey, Google, turn down the temperature 2 degrees. Hey, Google, begin Operation Kevin.
Operation Kevin underway.
Better get out of here before somebody sees us.
So this is the kind of applications and how they can change the life of people. With that, I wanted to thank you. I am very open to being connected. Please reach out to me via LinkedIn, add me on Twitter, and send me an email at marily@google.com. I'd love to discuss more about product management, about AI, about machine learning. And thank you all for attending this. And yeah, I'm looking forward to your feedback and comments. Thanks.
Okay, so since we're running a little bit late, I would like to thank you for the session, the speakers and all the participants. Thank you so much. I think it was very, very interesting talks and interesting questions and discussions. So I would like to give the floor to Professor Aristotelis Tympas, and thank you all for this session. Thanks a lot.
Hello. Hi, should we start?
Yes, please.
Okay. We're moving on to our first keynote speech. We're delighted, and I'm talking on behalf of the whole of the community of the ACM Women's Chapter, the Greek one. We're delighted to have with us as our keynote speaker, Professor Anastasia Ailamaki, who is actually a professor of computer and communication sciences at EPFL. And she's also the CEO and the co-founder of Row Labs SA, I hope I don't mispronounce it, which is a Swiss company that develops and enables digital transformation for enterprises through real-time analysis of heterogeneous big data. She was previously on the faculty of the Computer Science Department at CMU, where she held the Finmeccanica Endowed Chair. She has received the 2019 ACM Sigmund Edgar F. Code Innovations Award, the 2019 ETBT Test of Time Award, the 2018 Nemitsas Prize in Computer Science, an ERC Consolidator Award in 2013, the European Young Investigator Award from the European Science Foundation 2007, an Alfred P. Sloan Research Foundation in 2005, and no less than 10 Best Paper Awards in database, storage, and computer architecture conferences. She's an ACM Fellow, an IEEE Fellow, and also an elected member of the Swiss, the Belgian, and the Cypriot National Research Council. Before I give the floor to her, and I would like to remind you that we will have in the end some time for questions to our distinguished speaker. Those of you who want to use the special platform, the Slido platform, you can do so. I will type the address at the chat. Well, it's actually already typed. Thank you. And you can also, you may raise your hand and I will give you the floor. So without further ado, I may welcome Professor Ailamaki. We're all looking forward.
Can you hear me?
Very well, thank you.
Everybody good? Okay, great. I'm excited actually because I feel that I came for a little bit to Greece, although I'm not physically there. But It's very exciting, and I'm grateful for this opportunity to address you. So I'm going to try to fool my computer into also thinking that it's there with you, and try to share my screen if that's okay, Telly. Can I do that?
Yes, please.
Great.
I'm not Telly, just the voice.
Okay, Yuli. Hi, Yula. How are you?
It's Maria. It's Maria Ursu. Thank you.
Okay, sorry.
Okay, we can see your slides well.
Can you see a slide that says something, has a very cute logo at the top? Okay, can you see my slide?
Perfect.
Perfect. I can't see what you see, and that's why I'm asking, because I have this very elaborate setting here. So I have to tell you, we have about 50 participants today, and since this is way less than the 300 students I've been teaching this semester over this very medium, I would like, with your permission, to be able to actually answer real-time questions, because I'm about real-time, you know, so it would be really nice if people who have questions that affect their understandability of the talk, just go ahead and interrupt me. My students did that actually after I threatened them that I will not pass anybody who doesn't ask questions. So I'm very happy and very used to being interrupted and ask questions, and it's actually more fun for everybody this way. So and I have very modular material, so I can actually be adaptive over time. So I would like to discuss an idea. Actually, it's a set of ideas. It's a very high-level approach to building intelligent analytics infrastructures, and I call it real-time intelligence. Pun intended, you know, for artificial intelligence, because I think that artificial intelligence is a tool. Real-time intelligence is a set of ways to use that tool and other tools as well. So we need a lot of different types of intelligence to build expert analytic systems. This is work from my wonderful group. This is one of the many pictures we have wearing our logo t-shirts, and this was actually a couple of years ago, where I had a group that consisted, it was very gender balanced. You can see here all of this. Okay, this is my daughter, so she's not really a student, but she was there, so she put on a t-shirt. But there are 3, 5, 6, 7, 8 women in this group. So this is, you know, it was great. Now we have fewer women, but we're trying to change that. Because they graduated and they left and they got excellent jobs. So as I said, I'm working on data management, but data management by itself is not really important. Data management works, is at the service of applications. And data management also runs on massive hardware, right? And what we face, what we see these days is that data management, and especially data analytics, faces its most critical set of challenges. And I'm going to argue that the reason why this happens is because of heterogeneity. Things have stopped being uniform at any dimension that the data management systems are working on. So workload heterogeneity, you can think about it as basically the requests that the data requests that you have from a system when you're running e-commerce workloads, or when you're running healthcare workloads, or any other enterprise workloads, are very, very different from one another. They exercise totally different parts of the system. And these changes actually make the system behave differently for different kinds of workloads, or actually the optimal behavior of the system should be different for different kinds of workloads. Also, the data is changing a lot, and I'm going to get to this in a minute. As you know, it's going up in volume, but that's not the only way that it's changing. It's also being a lot more diverse in terms of formats. And finally, last but not least, the underlying hardware is exhibiting new ways of, is exposing new ways of software visible parallelism, the last one of which is due to the multitude of accelerators that are present in the socket. So this is an ecosystem in which this poor data analytics system in the middle that's been pre-coded to run select, project, join queries on tables, is going to be stretched all sorts of ways to meet the requirements from this multi-dimensional heterogeneity. And I'm going to start with, I'm going to talk about 3 game changers here. And these 3 game changers are going to serve a bit as discussion leads for some work that we've done that leads to this real-time intelligence idea. The first one is, of course, how much data has been growing. And the graph that I have here is until 2020, but the new EMC report has the same exact graph continuing in this exponential scale until 2025. So no surprises there. The data is growing in the most impressive exponential rate we've ever seen. And if you go in and you do some back of the envelope calculations and plot on the same scale how fast the processing technology has been able to crunch that data and turn that data into useful information, you'll see that there is a picture that's actually worrisome. There's a growing window of data. This window here, that's data that's never going to be read and translated into useful information. That's going to be write only. And you can think about it, you can see in many enterprises, we've got data. Most enterprises report today that they only use 20 to 30% of their data. And that's true also of a lot of social network information and so on and so forth. Moreover, what's really difficult to deal with is that it's estimated that about 1/3 of this data is inaccurate or lacking or missing some information in some way. So it's wrong. It's not useful for information extraction. In fact, if we use this data for information, we're going to get the wrong information. So giving this problem like 5 minutes of thought on how to bridge this window here, right? You can think of 2 things. One is that we need to reduce the amount of data that we clean and store. We need to put our effort only on interesting data. And the other thing is that we want to explore the data that we have more efficiency. So up our game here in this line and make it explore the data a lot more efficiently than it actually does. Okay? And I'm going to argue here that there are 2 problems. One is indeed the volume of data. And these problems are orthogonal. One is indeed the volume of data. The other one is the fact that we have to prepare the data before using the data. And here's what I mean by preparation. Anyone who's gotten their hands in a data management system or has heard of a data management system before knows that the data needs to be loaded or ingested in the system. So here I have JSON data, hierarchical data, that is tabular data in comma-separated values, CSV, and just plain text data. I have to flatten that out in whatever form is used in this database system and load it into the database so that the database can actually use it. But before it does, it needs to first clean it. So it ingests this data and produces a new version of this data, yet another version of this data, which is the clean data. And that's a hugely different chapter we're going to get to in a minute. And then after you clean the data, you need to tune the database, tune the performance of the database, look at the data, run some statistics, create some indexes, some auxiliary structures that are going to make the queries faster and so on and so forth. So that's the 3rd step, okay? And then after that, you're going to need, you're going to need to ask a question, okay? And you see, I would have to, from when I got the data, only after I've loaded it, I've cleaned it and I've tuned it, then I'm going to be able to ask a question. So much later than that. But then the system is not still ready to execute the question. It needs to allocate the resources that are needed to run the question that we asked, the analytical question, because a join of 2 tables together based on some columns, it might be done in many different ways. And depending on the statistics on the data involved, any one of these ways can be optimal for performance. So this is a performance step. Plan the execution so that it goes fast, and then finally run the query. And by the time we do that, a lot of time has been spent and a lot of money has been spent as well, because the cost of this exercise grows with how much data we own, how much data we loaded into the database. So the time that we spent to load is a function of how much data we own, not how much data we need. So we're going to prepare all of the data just in case. Okay. On top of it, this planning that I talked about here, what we also know as query optimization, is often wrong and actually pretty expensive as well as a step computationally. So net-net, all of this preparation is actually pretty time-consuming and resource-consuming. And I want to go to a topic, I want to dive directly to a topic that's really hard. How can we ever, do data cleaning without preparation? I mean, just wrapping your mind around it. And other sources say that data cleaning and organizing is actually a huge time sink for data scientists that ought to be really running models on the data and not cleaning the data and preparing it, right? So the way that data cleaning happens now is that you decide what kind of errors you need to clean the data from. You configure a software that's made to clean data from that kind of errors. And then you run that software and you create a new data set from your old data set, which is clean from that kind of errors. And then if you have multiple kinds of errors, you have to run different kinds of software. Okay, and this is a pretty tedious process and resource consuming process. So one of the things that we tried, and it seems like it's pretty promising, is to, instead of having to predefine what kind of errors we expect to find in that data, to actually start running queries and understand a little bit what kind of errors are involved in that data from their answers to these queries, and then model all of these different error detection and correction primitives through a common algebra to make them look like queries and incorporate them in a functional language that allows us to clean the data during query processing. And so to detect the errors in the data rather during query processing. And that actually helps a lot because first, you don't need to clean the data before. You start asking questions and then you realize, you find out what kind of errors you have. And then through the same environment, like SQL-like interface, you can start cleaning the data. And that's actually very promising. But then the other issue is, how do you correct the errors? Can we do that automatically, without having to, pinpoint the errors and then go back to that other software that cleans it? Well, by the same token, when we run queries, we first run the query and then we create a plan for that query and then we get the answer back to that query. Now, if we know what kind of errors, because we detected the errors here, right? We know that this may be erroneous data. What we can do is relax the query execution. So we run the query here, we create the plan, but in this plan, we relax the query execution by embedding in this plan data cleaning operations. So instead of creating a plan for the query alone, we create a plan that actually has some operations that can maintain, correct data that violate integrity constraints or eliminate duplicates or validate terms. So we get back through this query execution potentially more data and some dirty data, and then using statistics from previous query execution, so learning a little bit there, we can clean the data adaptively during analysis. So this is a very high level view of a project that we started, and it actually works pretty well for cleaning the data while analyzing the data. And the objective here again is to be able to, the moment we get the data, to immediately start asking questions without having to clean it first, right? So this is the cleaning part, and then just to see what kind of preparation we need except for that, right? So what is this preparation that we're talking about that we have to do on owned data? The first thing is, what data will be useful and what is its format so that we can load them. Then it's the errors. What are the errors that may affect our results? And that's where it actually pays off to clean the data adaptively, as I said, because you're not going to clean for errors that you don't care about, right? That are not on data that you process, right? So then which are the data that are mostly used? Which are the hot data? And you're only going to invest on indexes and other auxiliary structures on that data. And the last but not least, what does this workload do so that we can actually plan the operators, the processing operations correctly? Does it do queries? Does it do transactions? What does it do exactly? Now, here's the paradox. We can only make data analytics efficient if the workload meaning data and queries, is known ahead of time. Because the only way we can make the processing efficient is to have coded a system that has the answers to these queries. If you don't have the answers to these queries, you can't make an efficient system. So we're doomed from the get-go because this database system that we have pre-built does not know what workload, does not have the answers to this question. So it only has general solutions to offer that are by definition suboptimal. What we really would like to have instead is a system that doesn't make any assumptions in the beginning and rather employs a pay-as-you-go philosophy. A pay-as-you-go philosophy in that system will first have the data, have access to the data.
I have a question.
Go ahead.
Yeah, okay. So this is Yulia Fatourou.
Yes, I heard.
So how do you define what is Iranneus or what is correct? So does this have to do with just the integrity constraints, or does it have to do with the output of the query as well?
Yulia, this is a perfect question. You don't define. And this is exactly, you just nailed it. You nailed the heart of the problem. You don't define what's erroneous. What's wrong for you might be okay for me. You know, if we work in different parts of the hospital, for example, and we both receive the results of an MRI machine, and you care only about 2 decimal points, where I care about a lot more decimal points, right? The error there might be critical for me, but it might not be critical for you. So actually, you nailed it. The way that you define, that's why I said you want to do this here. You want to do this while you're running the queries. You want to have a language or an extension to your query language that allows you to check and detect errors. Okay, so this is an enrichment to an existing query language, this algebra that defines different kinds of errors, and there may be hundreds of different error definitions that you add to your query language. And we've done this in our system that I will describe in a minute. And that actually allows you to define your own kind of errors and inconsistencies.
Okay,
Does this make sense?
Yes, it does. Thank you very much.
And that's exactly the problem, right? So, so as I said before, ideally what we want, right, to be able to have our data and immediately be able to ask a query, because guess what? I don't care about how the database stores data. I don't care if it does column store or row store. I don't care what kind of indexes it has. All I care about is what my data mean to me, okay? So I have a question to my data. I don't have a question to my database. I have a question to my data. Databases should not even be visible to the user. So what we want is a system that accepts the query, knows where the data is, but has not really gone through it. And then using algebraic definitions like the ones we can use to define the cleaning function, we can use algebraic definitions to define anything, scans, joins, anything you want, okay? Using these algebraic definitions, at that time, generate the code that corresponds to running this query on this data. And then after you generate the code, you run this code on this query, to this data, and then you get back the result, and you're happy. And here, while you're running, you can keep this data because, you know, the first if you do this every time, it's going to be really tedious and slow because this is raw data. It hasn't been prepared, doesn't have any indexes. So the first time it's going to be slow, but to make the next times faster, you can keep what data has been useful and what queries also, what code has been useful. And you can reuse it in next queries, taking advantage of the locality that's evident in user streams. So your database, imagine if this system existed, right? Your database is the memory of the data that you have needed. And your data to query time is 0 because the moment you received your data, that's the moment you can ask a question. So we're going to get back to this, okay? But here I've addressed the sort of the preparation part, okay, and the cleaning part. I want to address, before I move on to deeper into this data to query time 0, I want to address a little bit the big data part, the volume part. Like, you've got a lot of data, okay? And a lot of times, sometimes, yes, you need only 20% or 30% of the data and you don't know what that is, or you have to prepare the whole database. But sometimes you might need a lot more than that. So running through the whole database is okay when you're asking for a balance of an account or stuff like that. But if you need like averages or any sort of approximate aggregates, you might be able to do something to just get fast insights of your data, although the answers might not be accurate. So we're looking for approximate answers with accuracy guarantees. And this is a part of our work that's called approximate query processing. And it's actually gaining a lot of interest now as the volume of the data is increased. So the premise, go ahead. Go ahead.
You have a huge volume of data, but it's a static collection, right? So you don't have, yeah, okay.
Yes, so this is your classical database of a lot of data, but you decide that your queries are running very slowly. And what you want to do is to say, you know, instead of me getting an execution time that goes up with every query just because my data is a lot, what I'm going to do, and this is actually happening, is ahead of time, before I start receiving any queries, I'm going to create a database of samples. So I'm going to run through all of the data, and I'm going to sample it. Say, for example, stratified sampling, right? So I'm going to use a nice little sampling algorithm that's going to create another database. And that database will be a pretty accurate image, but much, much smaller of the one that I had. So it's just sampling, right? Leaving some values and getting some others, right? Keeping only a part of the database. Right?
And the queries that you want to answer are kind of general, or?
Yes, but you're getting to the problem, right? Perfect. So these are the queries. And the problem, of course, here, although if you have hit the spot and the queries are going to be answered relatively accurately, you might actually get great performance, right? The execution time goes down with the query sequence. You see this, the difference here? But at the same time, you are going to get the approximate answers with the guarantees that you want. But how do we know what queries we will be asking, right? So and then of course there's many approaches, there's online, this is called offline approximate query processing. When you get the samples, you create the sample database ahead of time, and then you run the queries on it. There's other approaches to sampling, to getting the query and then sampling and then running the query on the sample. There's tons of work on approximate query processing, but what we realize is that all of this work requires preparation, either per query or in the beginning for offline. So instead, what we tried was to actually, instead of creating something in the very beginning, not create anything, but start sampling while we're running queries. So learn from what the queries are asking, what the hot data is, and get a sample database that actually has learned from all the query stream that you've run before and is continuously updating itself. And this is really promising because it gives you a query execution time that's much lower than even the best approximate query processing algorithm you get. And it only breaks and goes up if you actually completely change the kind of queries that you do, okay? But people who run analytics run interactive analytics, one after the other, the queries on the similar data, so it actually makes sense. So this works really well, and you can see how machine learning creeps into the fundamental functions there to help us really help us with what we need to do and be a valuable tool there for database processing. I'm going to get back to this preparation part here, but not before I tell you why. The biggest problem of preparation isn't volume, isn't velocity. It's actually variety. The data comes in so many formats that it's just impossible to flatten everything into a table without jumping through hoops, and still you lose a lot of information. So creating a data system for all data and applications in this classical form is really hard. And I can't help but giving you here a fun example. Well, it talks about Alzheimer's, so it's actually about trying to help sick people, I guess. But it's the data that's fun there. The data comes from many places, right? So I was working in the Human Brain Project for many years. And there, one of the fun things that I was doing was helping doctors with clinical data, okay? And they were trying to find new subcategories of Alzheimer's disease. And there they had to create what we called biological disease signatures, which are basically strings that encompass all the characteristics of an observed Alzheimer's variant. For example, clinical data that come in that are observed on the patient, biomarkers, protein levels, genomic data, and then of course all sorts of X-ray style structural biomarkers that you may have. So all of these can come together and produce a signature for an observed disease variant that basically says that if someone comes into the hospital with memory loss, it's the tau protein level is it exceeds a threshold, and then they have an atrophic hippocampus and an amyloid, they probably have the so-and-so variant, right? But from the data point of view, what this means is that we have, say, 3 files. One is the patient's file. That's all of this clinical data that's been observed about the patient. Then we have this binary file that actually gives us a picture of what's happening in the amygdala region, which is, it's a volumetric, essentially, measurements from the amygdala regions. And then this JSON file, this hierarchical file, is derived from this binary file. And in order to produce the signature that I was talking about, I would need to run a query that for all of the tuples, all the patients that satisfy this 3 conditions here. And this query would have to essentially join all of these 3 files. But these 3 files are totally different, right, in format. Okay, so using a traditional database, I run this query. Here's the query. This is SQL for those of you who have been, in the databases with me. This is SQL, right? So, you say what you want to see. You say where the sources are, brain regions and patients. These are the 2 files. The one is JSON, the hierarchical, the other one is table. And then you say what are the conditions that need to be met. So you feed this into the query optimizer, then the query optimizer will give you, here's the plan that you need to execute in order to answer this query. This plan needs to scan the files and then filter the first one, right, for this, for the amygdala volume, and then join the 2 using this ID matching here. Okay, so this is what it does. And a classical database system is going to first have these files loaded into the system, into tables, and it's going to flatten the hierarchies here, and then it's going to use these scanners to scan the tables. Okay, and of course that involves a lot of preparation. So instead, we did what I said before with code generation, and in an engine that's called Proteus. So what will Proteus do? Proteus will not have this database part in the middle. Okay, what it will have is this a generated plan as before, but the moment it receives the query, it will generate this plan, but it doesn't have the loaded versions of the files. It has only the raw version of the file. So it's going to go, first of all, and code generate access paths. Code generate means it's going to spit out code. It's going to have the scan operation, and it's going to know what kind of file this is. It's a hierarchical file. It's going to write code to traverse this file. And it's going to write code to traverse this file. That happens during execution time. And then it's going to write code to do the filter and join operation. Now, as soon as it's written all of this code, it's going to execute the code on these raw files. And then while it's executing the code, it's keeping the useful info in the caches, in memory, in caches, like I showed you in the higher level picture before. So if you look at it from the user's point of view, the user will ask a question that perhaps involves many pieces for many different source files. And these, in the general case, can be an Excel file, a relational database, a JSON file, an ODB, MongoDB file, text database, and unstructured machine logs, right? So that you can have any kinds of data sources, raw data sources, because the system, the moment it receives the question, it will break it into pieces, one per data source. It will generate access paths and filtering for all of these data sources. Then it will discover what are the interesting data, and that it will do because it knows the query. And it will also keep the interesting data in this cache. And then you will have the answer come back to you because it will run the code generated system. So the data is accessed and also integrated in real time. And that's what is the manifestation of the real-time intelligence. The query plan itself is actually done also using machine learning algorithms. I'm not going to go through it now, but I can talk to you offline if you're interested in that. So now, sorry about that. So now what I want to do is just to summarize that what we did here is we created a system that allows applications to see all sorts of variety of data through a virtualization layer that makes all the data look like one. So it harmonizes the data. Okay. And that's what Proteus does. And how we do it? It's with code generation just in time. The moment we have the query and the data, then we code generate what we need. It's like generating a tiny little database system for every query that you have. Last but not least, I would like to talk about the hardware, okay? And all that the microarchitecture has ever given us has been parallelism opportunities, okay? Implicit parallelism opportunities and explicit parallelism opportunities. You've seen all of these three-letter abbreviations, right? Instruction level parallelism, memory level parallelism, thread level parallelism. The multi-cores have given us the CMP, and then you've got non-uniform memory access. You can run. This is a picture that I like to denote the sockets with many cores, many compute elements in them, right? And these are also connected. So there's no computer with one processor anymore. Even your phone has more than one processor in it. Okay. But what happens today, just to make our life a little more interesting, is what my former student Ryan Johnson calls the Franken chips, which is like Frankenstein on a chip. It's basically chips that have so many different kinds of compute. Before we just had the CPUs. Now we have GPUs, we have FPGAs, we have NPUs, network processing units. And you're going to ask me, why do we care? Well, we care for two reasons. One is these things are actually taking real estate on your chip, and you pay good money for them. So, people have recognized the immense power that these additional compute infrastructures have to offer, and they are actually creating very easy to program environments, and they're making them faster for use, not just for their original use, which is for GPUs, for example, to draw on the screen, or for graphical processing units, right? But also for processing. GPUs, especially graphical processing units, have the characteristic of running several thousands of hardware threads at the same time. So immense parallelism, right? And they can be used very efficiently for data parallel tasks, such as data analytics or OLAP, okay? The question is, how do you know from the software? Do you want to be hardware conscious, so write code that observes these intrinsic characteristics, or do you want to be hardware oblivious? And I have been dealing with this question for 3 decades now. And the problem is portability versus performance, right? If you write code that doesn't observe the hardware, you get very portable code. That code actually can be running on any machine, but the performance isn't going to be very good. It's not going to be as good as if you write code that's conscious to the hardware, that observes the characteristics of the microarchitecture. But then if you write that code, you get the high performance, but then you get very low portability. Your code is only going to run on devices that actually observe the same characteristics as what you had in mind when you wrote it. How can we solve this trade-off? Well, thinking about what we do when we run queries. What we do, and you saw my pictures before, what we do is we take a question and then we break it into small operators. Some of them read files, some of them join 2 files together, some of them filter files, right? All of these operators are small programs that run by themselves and then operate with other small programs as in a producer-consumer relationship in that query plan that you saw. So we could do processing in a selectively oblivious way. If I have a lot of CPUs and a lot of GPUs in my system, what I have is a bunch of compute elements, a set of them that look blue, look like CPUs and have the capabilities of a CPU and the characteristics of a CPU, and a set of them that I'm going to be denoting as green and have the capabilities of the GPU and the characteristics of the GPU. So if I do different things in these 3 different dimensions, I will be able to have the cake and eat it too. So first I observe the operator in and of itself, what it does, how it uses memory. And if I'm on a GPU, I'm writing specific operator structures for the GPU. And if I'm on the CPU, I write another version of that operator for that CPU. And that's called the intra-operator dimension. Now, as soon as I do that, how do I enact those operations? Well, I don't know where I'm going to be, if I'm going to be running on a CPU or on a GPU. When do I know? I know that at the last minute, when the job is assigned to one of the 2 elements. The moment the job is assigned to one of the 2 elements, I've created mappings, which is what I call intra-device. I've created mappings which specialize the right code for the environment that I'm running it in. And I enact those mappings through just-in-time code generation. And that's what I do in real time. And then, last but not least, I need to orchestrate all of these devices together and all of the operators that run on these devices, for the first time observing that in the same machine, there may be more instances of the operators running on many instances of each device. And that's called inter-device, where I need an execution model that encapsulates the heterogeneity of the device. And this is very important because we're entering the era of this new 3-letter abbreviation that's called ALP, accelerator level parallelism, where all these accelerators, we've done the work for GPUs, but you have FPGAs, you have all sorts of other accelerators, are going to be first-class citizens, not only because they offer a lot of compute capabilities that are very attractive for computation, such as analytics, but also because their presence on the chip. I mean, you don't want to have idle devices, right? So you want to use everything as much as you can. So here I'm gonna see. I mean, we did quite a bit of this work. We have a few concept. You know, ways to show not only that this works and can happen, that this three-dimensional abstraction actually can be realized, but also that the performance of the systems is better when we have the devices collaborating with each other. Because what you see on the market is systems like these blue systems here. Here we're running a benchmark with a lot of queries. It's called the SSB benchmark. And we're running first a commercial system, that's the striped, that does only CPU execution. Then we run our own system, but with only CPU execution. Then we run a commercial system at the very end here with GPU-only execution. Then we run our own system, Proteus, with GPU-only execution. We had already projected that if we actually did a collaborative work between CPUs and GPUs on those queries, we would get about this execution time. And this is indeed what we get. So the execution time is always higher, lower. The performance is always higher if we reap the benefits of all of these devices that are present on the machine. Just to wrap up here.
May I ask you?
Yeah, please go ahead.
What is your benchmark here? What is your
It's SSB. It's called the SSB benchmark. It's a benchmark which runs a bunch of queries. And you've got here a little bit of the experimental setup, but basically it's a benchmark with analytics queries. It's pretty common.
Okay.
And we've run it with TPCH and all that stuff. But this exhibits the very nice property of having a lot of queries, a lot of different ones. So yeah, go ahead.
So my question, my question is actually, when you have GPUs, you indeed have computational power, but the time to move the data in the GPU memory is pretty high. And especially if you want to move data, a lot of data, then the transfer time is very slow. And it's not sure that it would be beneficial to move all this data to the GPU, although if you had them in the GPU, it would be beneficial to execute some computation there. So how do you decide the compromise? I mean, how do you have models to study, or what is the way to study whether it would be beneficial to use the GPU for some part of the computation or not, and which part is this or what? So this is what I was wondering while you were, I don't know if I missed something, but this is what I...
So let me show you something. Can you see this slide?
Yeah.
Okay, here's HTAP. This is a hybrid transactional analytical processing where I have OLTP task parallel running on CPUs, and I've got OLAP, which is data parallel running on GPUs. And what I want to do is I want to send OLTP to CPUs and OLAP to GPUs. And what I want is to be able to also run analytical queries on both CPUs and GPUs when CPUs become available, because there's just not enough work to do on the transactional side. Okay, so far?
Okay.
The interconnect is actually, so it's DRAM. The DRAM interconnect from CPU to main memory is the fastest one, right? From GPU to main memory, you can have variability on the interconnect, and the link is almost as fast as DRAM, right? PCIe, PCI Express is about 3 to 4 times slower than NVLink. Also on the GPU side, you may have a variability with respect to what is the speed of the GPU itself, of the device itself. So the server GPU is 3 or 4 times faster than a desktop GPU. Now there's 2 interesting points here. One of them is that this is what you're talking about, this interconnect here. And the question is, you got a fast CPU and a fast interconnect, or a fast CPU and a slow interconnect, or a slow CPU and a slow interconnect. How does this play together with you having to bring the data? Well, the data always comes first to CPU and then is in DRAM, and then you have to
exactly
CPU, right? So how do you play with that? So the first question, right, is what matters most? And interconnect, it turns out it matters way more than processing power. So here's GeForce. This is server grade, okay, and this is server grade GPU, right, with PCIe, which is the slow interconnect. So slow GPU, slow connection, and you see we're running the same benchmark here, the SSB, right, and you see that it's actually, and these are different ways. Don't worry about what these different three different bars mean. This is from different talk. It's just how you transfer the data local to the compute unit before you start running the query, which is eager, or on demand, which is lazy, or a hybrid, which is semi-lazy. But you see that things are slower with slow GPU and slow interconnect. So here's what's interesting. I make the Tesla, I replaced the GeForce with the Tesla, and the Tesla is actually a fast GPU. It's a server grade GPU, but I don't replace the interconnect. And there, I'm running the same benchmark, and you see, I don't see a huge impressive difference in time, although this is like a 4 times faster GPU than this one. Tesla is way faster. And then at the very end here, what I do is that I have the fast CPU, but GPU, but with the fast interconnect. And this is GPU only execution, so it's not collaboration, right? This is GPU only, so it's exactly your question. And you see here that the execution time immediately drops the moment I drop I raise the stakes in the interconnect. So that's your first question. And your second question, what's really interesting here is what I see is that there's going to be actually a big change here, because CPUs don't have a lot going on in terms of communication with the rest of the machine. Between them, you have 32 gigabytes per second, whereas you have a lot less, like a third less of the bandwidth when they talk to other GPUs or to the network. Okay, so bringing the data to CPUs and then everybody else asking CPUs to give them the data doesn't scale anymore. So the prediction is that we're going to have the data shipped directly to GPUs or to the NIC in order to be processed, and they're going to be accessing through RDMA. And that's what we call accelerator-centric OLAP engines. So this is a long answer to your question. I'm sorry about that, but hopefully it's fun to, I mean, it's just fun to see these things, right? Okay, so just to not tire you too much more, I want to say that you remember before we built this data virtualization layer to hide the differences between data formats from applications around? With this new work, we actually build another virtualization layer to hide the variability at the hardware level when doing query processing. So essentially, we need these 2 levels to make heterogeneity invisible, okay? So that applications become portable, but at the same time, thanks to this harmonization, is efficient. And I'm gonna finish here with a realization. What we have been building until now is prefabricated intelligence. We think about what we want to do and we write the code. To run analytics, however, because of all of this tug of heterogeneity that I showed in the beginning, this doesn't really work anymore. What you want is to take this intelligence that you built ahead of time, right? And make the intelligence real time. So there's a difference between intelligent real-time systems and real-time intelligence in systems. Replace all of the static decisions we ever make with automatic adaptation using mathematics. We use category theory, monoid comprehensions, code generation strategies, and machine learning when needed. And it turns out that a system is only as efficient as its least adaptive component. And that's all I had to say today. I'll take more questions now if you have any.
Thank you very much. Questions?
If nobody else has a question,
I think Eula, I'm going to need you to come here and work with me because I love your
I would love it. So, how far can you take this idea that you just described? So during your entire talk, I was thinking that all of what you said in your last slide, that this is a very nice idea of trying to learn as you go, and then use this knowledge to make the different components of your system more intelligent, so better in a sense. So I'm not a database person, right? But so how far can you take this idea in the database research? So
to be honest with you, I'm planning on taking it pretty far. We have been working on this both on the academic side, but also our spin-off, Raw Labs, is commercializing a part of the system. Not of this system, it's actually built a different system, but it's for analytics infrastructures, and it's actually commercializing many of these published ideas. I believe that we can take it pretty far. I mean, in my mind, we grew up thinking the database systems are the center of the world. And although that's true, the users really don't care about database systems. And that was the biggest realization I had. I was talking to astronomers and I was telling them about how they can join two tables with objects from the sky that their telescope has observed. And they were looking at me and asking me, what is a join? And I was thinking, how can you not know what is a join? What is wrong with you? Well, it turns out that most people do not know or care what a join or what a column store is. And this is where, as a community, we need to up our game. The operating systems community, for example, they started from us having to program, Digital Equipment Corporation, green, machines there, and having to know exactly how VAX VMS works in order to do anything serious with the system. And they went from that point over to now that nobody ever cares what operating system they're running on, right? Nobody acknowledges it. So they've made all of these services invisible. We need to do the same thing. So I think this is these little words, these two little words here, this transposing is basically the key to making it to that level where data management is going to be invisible. And the only thing that people will be seeing is what they really care about, which is their data and their questions and nothing else. So that's how far I want to take this.
What I meant was that, in the database community, you have some hard problems to solve. For instance, the database may be distributed, you have to distribute the computation appropriately, yes. And this depends on your access pattern, and you don't know what the access pattern might be, or you have to build the right indices, and you have to decide what will be the primary keys, what will be how many indices, how many levels.
So there's tons of work for that, right? There's tons of work for that.
So can you use this idea to solve all these different problems?
Yes.
This is my question, actually.
So we started in the data.
They're kind of fundamental, right, in your community.
Yeah. So we started with trying to do self-tuning and self-management. And actually, query optimization in itself has so many magic numbers associated with it. You won't believe like how much more expensive is this operation than this operation. Let's say 10, and that's it. And that's hard-coded in the system, right? And I mean, it's crazy. So people have recently started using machine learning to get rid of some of that and help self-tuning. But I think this is the umbrella idea, because machine learning is a tool, is a way to, but we need a policy. We have the mechanisms, we need the policies. So yes, absolutely, this is exactly the playground that we can use to really benefit the community with these kinds of things. And code generation, I think it's a magical thing. I mean, It's really great, and combined with mathematics, because in the end, data is everything that you can define mathematically. So mathematics is the beginning and end of everything. So code generation combined with this power of mathematics and really having ML as a tool can give you exactly the next level of systems that we need to cope with all this heterogeneity.
Mm-hmm. I apologize if I have monopolized the question session. Thank you.
Thank you very much, everybody. It's a pleasure.
Teli, you are muted.
Yes, no, I don't have a question, just a very brief comment. I actually find the concept of heterogeneity, especially in the context of what you suggested to us, very important, because it's also a gender-sensitive concept. And to make the case, I don't want to take any time, I just put in the chat a reference from a scholarly article on the sociology of heterogeneous engineering that concludes by stating exactly this, that advancing the role of women in engineering, the placement of women in engineering, will come along acknowledging the importance of heterogeneity in engineering. So, yes,
oh yeah, so that's
the point from sociology of computing, sociology and history of computing, to confirm how.
Very cool. Is that the one you just shared?
Yes, yes, you can see it in the chat.
Yeah, I see it. Thank you.
Yeah, so Telis is not a computer scientist. He comes from the world of history of science and sociology, and yeah,
nice.
To add his own view on the topic, which is very interesting.
Is there any other question? Doesn't look like it. I don't think there is any question in the other platform. Let me check. No, there isn't. So we may thank Professor Ailamaki very, very much for this wonderful talk. Yes, thank you very much.
Bye, everyone.
Bye-bye. Thank you. Maria, I guess that we have to decide how big the lunch break is going to be. And
yes, we're at a half-hour delay, I believe.
I think
so. It would have been time for us to come back from lunch at this point. So I'm sure we need to break for a bit because everybody may need to break. Should we
go for 20 minutes or something?
Okay, so should we come back at 2:35 then? That would be 2:35 EEST Greek time.
Yeah, or 2:40, something like this.
Okay, so we'll be back. Have a good, even if